Assalamu alaikum friends. In this video we will learn how we can configure linear in TIA Portal V16 PLC using S7-1200. This I have a one linear that's I show you if it can be possible to show near the camera. This I have a one a resistive linear, right, and this will we will configure in PLC, and I will open that tag mappings app 16, and also we will discuss how we can configure in HMI, show the value at our HMI. I have one this HMI that I show you, that Ventic HMI, that model Ventic MT SC Qatar IP. Okay, so let's start. Open the project view, and then go to the program blocks and insert the main organization block 1. Simply that's the previous lecture for servo, but here we will make for our analog input of a linear. First of all, I will show you how we can configure this linear. Go to the device configuration, you have to be keep patience because that Siemens TIA Portal is little heavy software. Go to the properties, and here we can configure. First we have to be check that analog inputs and this analog outputs. Analog outputs have a address IW64. No, sorry, analog outputs have QW64, and analog input our channel 0 address have IW64, where we read our value of our linear that using IW64. So simply we will go to the organization block, and here we will take one move command, and simply IW64 we will write here, and we will take this data in any data register MD100. I will use for MD100 to our value to see in PLC, and that's here already we use that QW64 in MD10 that for servo control, but if we like to delete this one, we will delete this program, and copy and here paste, or otherwise we can take this network. We can go in network first. That QW64 is our analog output. This why I am using, because that QW64 I will give the voltage from the PLC to QW64 is the analog output, and I am using the voltage power supply of my linear of the analog output of the PLC. So I will give some voltage, look near around 12 or 13 voltage, which is variable with our linear. Leave it this one. We will make it here now. In one row we will make a little understand after move command. IW64 and data register MD25. Okay, let's first we will check this program to the PLC. We have to make program. The PLC and then start search. And then click load. And again click load. Make the simulation on. And that display I will change to the decimal to easy understand. That IW64 also we will change in decimal to easily understand. That's QW64 is my address of analog output. So with decimal, if I write it here 100 and then I see here is 859, yani means look like near around 1 volt it will be generated. So I will change this value for 200, that this value 27,000 2798 look like this value generated to the my analog input. So now our linear is shown at IW64. Example, this is our linear total value of our scale. I will show you in camera. See, for example, this linear, this camera I will take it little here at the side, and then you can see when we take our linear value it will be reduced. It will be when full, if going to out it will be good as near 400, 300, 100. Now 0. Example, this our length of the our linear from here to there. This little I make it more little here, but you can see easily. And if from this area and to this area is, for example, 1 feet. 1 feet means 12 inches. This value, how we can measure this 12 inch? This, see, when it's going totally closed to the condition, this linear is generating the bits journey. See, it's now total bits. How much? See, 2764. Example, this 2700 consider, and if our this 2700 bits are equal with 12 inches, so first we will make the formula to our program. Go to the math function, go to the math function and you make the division command, and data we can take in dint or int, and you can choose, and here we will put this value, this our IW64, that MD25, MD MD MD25, and here we take another data register MD35, because of multiplication data we will take that one, and we will take the answer at MD45. And this why? Because showing this is we using the MD data registers, we have to make it in dint after it will be cleared, and download to the PLC, click it load, and make it simulation on. And that's I will make also display format in decimal, and this also display we will take in decimal. And here we will give, we think this is the 12 inches. This is coming 18. In decimal we will go, and for example 15 inches, for example, that you consider 15 inches, that's your 15 inches. That's the answer coming 182, right? And here now we will take at 182 in decimal 180, for example, and that's you can make. That's when with this value, when we make it the division 180, and total length is our of the linear, that this length, total length of this linear is 12 inches, 15 inches, for example. And how much measuring this length we measure, when it's starting working, yani this is for example 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 2, 3, and now it's full coming, that 0 for example. See, now it's totally open, and this is your 15 inches length. If you're measuring with by tape, after you can easily understand how we can multiplication that make that linear. Where we like to stop, yani means 1 inches like to be open, 2 inches like to be open, 3 inches like to be open, and that's you can be calculate very easily. MD45 is your inches in calculation. Any formula when you're using that your linear 15 inches, 20 inches, which is your linear length, that you can make that's bits multiplication with this original value. After you can find your real value 15. And after how can implement in the program, that small example I will give you. In this row we will take one next row, and here we can use the comparative commands. That's equal or greater than command used, and after we can use one output, and here we can choose MD50 and MD55, and that's you have to be decide which data register you have to, sorry, not this one, dint, and that Q0.0 we will choose the output. Q0.0 choose the output. Q0.0 is our output. These tags are showing that rename also you can change this, the rename tag. Rename the tag, and you can give start motor for example, to start motor, or any you can give it here, and that's we will download to the PLC. This and anything you can using, for example this linear is sitting with any mold or something you like to 2 inches when रोटिंग आ जाओ 1 सेकंड बस मैं करके आता हूँ. That's when you using this value, that making decimal format I will choose in decimal. This also format I will use in decimal. Okay, and that's the MD50. No, sorry, this I have to be use MD. That data register we choose wrong. We have to be change MD45. That's our linear data register, which is shown value anyway. And MD55 we have to be put value how much after we have like to be start or stop our command. That's MD55. That MD55 we will choose, for example, 5 5 inches. I say that 5 inches after this have to be open or close. MD45 is rename the tag, set value. No, we will choose that one. This data register. For example, 5 we write. Later on I will give you the example how we can take this data register on the PLC. And see, this 5 value is when our linear value is 5, that our Q0.0 will be stopped. In first see 13, 12, 11, 10, 9, 8, 6, 7, 6, and as our value increase from 5, our Q0.0 will be stopped. And as this value will be increase, our Q0.0 will be start. And this will be varied in your see, right? And same as that value will increase equal or greater than 5, our Q0.0 will be energized. And that seems look like yani this is your length. For example, this area is 5 inches or 5 inches when you think, and can be measurable 5 inches, 6 inches, which you can put it here. And also, if you like to use this with data register, yani how we can take this value at to the HMI. So I will show you. We will stop our that system and we will open our Easy Builder Pro, and these values, this MD45, and here we will put one data register MD45, MD55. This will be our set point will be of our motor, and that's we will be download to the PLC again, and then click OK, load to the PLC and make it simulation on. And that's when you write it here, for example 10. This is in hexa, you have to be going 10, and that will be closed. As your value near around correct at 7, 8, 9 and 10 as your Q0.0 will be energized. See, same we will open our that HMI program. That one old we will open, no problem. That's for example, that first we will make that one speed set. That way length 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 set. Okay, and that data registers we will take set point MD 55, which is our set point, and let's leave it this M0.0 that we will be use, and only that one we need. Only we designed Q0.0 only, and if we need one more value added here, example here we want one more take row move command, and MD45 move into oh sorry, not move command, that's we have to be use that compare command. Equal or less than, first we use this equal or less than MD45 and MD60, and output that's we used Q0.1. Q0.1. The tag leave it, no problem. If you change that, rename the tag any, if you no need, it will be became stop motor, for example. Your stop motor, that can be changed, and here MD60 you have to be less or equal this data register, and equal or greater than this is MD55, and that you download to the PLC first, and this value we will take in decimal format, in that format also input decimal. Okay, and this set point still we not give MD55 and MD60, this we have to be taken our MD55 control C and here control V. That's we can make MD55 or MD60. And this program we will download to the HMI, and then we see HMI name, IP, search all, and if your HMI is connected, our port number, 192. That's our PLC addresses. How much? That's we have to be check. Our HMI address 'on that our HMI we have to be calibrate. Where we take it power off. This will be start, I think so. Yeah. Search. Now you can download the program to the HMI. Now it's downloading. Our camera is running, and in our HMI also. Yeah, our data is now ready in the HMI, and this value only we will see in our PLC. That's for example MD60. That's we give the value from the HMI, and this is our Q0.0 is now on MD60. This is for example 5, and this is now closed. This data also we have to be put in. Set 5 MD55, and that one we will 6 put 9, and that's value is changed to the 9, right? And if we change this one, this will be 10, and that's value will be changed here. And that one value in decimal change 9, and this data register I think so. This value is going in hexa mode. This we have to be change. MD55 and MD60. Let's first we have to see our this data register, which is we defined MD60 and MD55. MD55. MD55 and MD60. MD55 and MD60. Again download to the PLC and then click load, finish, and make it simulation on. MD55, where is our MD55? This value is Y showing in hexa. D int decimal, and here this which here is our value have a problem. MD55 we were using here. MD, that format we have to be check. We used that 32-bit unsigned, right? And here we will use format 32-bit unsigned, direct, and this is also direct, I think so. Allow input, okay, and M60 also allow. That again download to the HMI. And when we all finished, after you can make it exit. That MD55 5, that's data register. Why this doing look like? And decimal, put 5. Yeah, it's now okay. Here we will write after 6. It's coming hexadecimal coming from our HMI setting. We make some MD55 read write and format decimal of 5 4. MD60 direct 5 4 default, this also default non direct Again download. And when all finished here come, after we can make it exit. MD45, MD25, MD10, MD45. Oh, this data register we have to be changed. MD60. This one we will be make it MD100 can make no problem. And again download to the PLC. Click load. That now here also we have to be changed. MD100 and download again. Download. All finished. After close. And this one more thing here we will put 9 for example. It's quick 9. Now it's okay because of this MD55 and 60 inside. This is the interrupting the data. See here first we have to little make changes. Value 6. Click OK. Next. Next. 9 and 10. See, when we change this data register from value here, we will put, for example, 6 and make it enter, and our value is now changed. And now this 6 value is this MD45 is bigger than 6. As we make this increase this value, see this our Q0.1 will on, and as this value decrease than 6, after Q0.0 will be off. And here also our HMI that will be shown our. This is the 6 value shown, this is the 10. See, this is the 6 MD60, MD100, sorry, MD100 is greater than 6, our Q0.0 is stopped. And as we make this 8 for example, and our Q0.0 is stopped. let's put it 10. And this is 9. This is 9 entered. And this is 8 entered. And as our value will be changed. See, this is the smaller than less equal with, yani this is we make it the set point, yani MD45 when equal with 5 or less than 5. After our Q0 dot 1 will be of less than 5. Less than 5 means when you put 4 and our Q0 dot 1 will be stopped. And as this will be going to increase, we check it with the linear. As this is will be increase, our Q0 dot 0 will be on, and as it will be decrease value as going at the 4, decrease from 4, our Q0 dot 1 will be on. Our camera is now little interrupting. That's network, I think so, have some problem. That's internet is a slow here. This little take time. See, as this one is greater than 4, to be Q0 dot 1 is on. So I hope guys you understand how we can use linear in Siemens PLC and how we can make the measurements in the program, as how much this length you like to make this one, how much bits coming from the your linear in real value. That's you can multiply, make the formula for multiply, and as it's going at the 0, this is your full length, yani how much your length of the value. This you can select it here and measure how much length and how much your total bits. That's you can make it division with this data distance, and after you can easily operates the system. Any in this will be can be a hydraulic, can be a any load cell, can be a mold, or can be a with the conveyor. Any program, this commands you can use and you can control your length. I hope you understand about the this commands, how we can use our linear value read in PLC. And also here when you configuration, make the simulation of, and that's PLC. Here I think so. Yeah, here not showing, but this your analog, you can see it here, yani. Here when you don't the take you, that's your value, and that's analog. You can check in your properties. When you go to in properties, can easily find it here. First are the analog inputs. Here all this details. That's digital input and outputs details. And here in second option, and here in second one, A analog input and AQ2. That's analog inputs channel 0. This is your data register for reading, and this is your analog outputs. That's analog channel your output where you can write the value. So I hope guys you understand about this video. If you not understand anything, you can send me message in comment section or send me email. I will give you feedback as soon as possible. Thanks for watching. Allah Hafiz.